another example. Let's take a long, thin wire, and let's run some current down it. And let's say that this thing is pretty long. L is 175 meters. There is some voltage which is driving current down this thing, and so there is some voltage difference between the two ends. And let's tell you that that voltage V is 0.3 volts. And let's tell you that the amount of current flowing in this thing is 125 amps. And let's say that this thing is made up of aluminum. Mass density is of aluminum. So this is an aluminum wire, is the following. Mass density rho is 2,700 kilograms per cubic meter. And let's do the following. Let's find the total mass M of this wire. Okay, it might seem like we don't really have enough information, right? Because we just talked about how much current is flowing, and somehow we want to get the mass of the wire. Seems a little strange, but the key is that it's aluminum, and we know a little bit about aluminum. So how do we do this? Well, mass, M, is just going to be the mass density, rho, times the volume. Okay, mass is density times volume. But we also know a little bit about resistance. We know that resistance is going to be R of aluminum times L squared over the volume. And we derived that a second ago. And so now we can rewrite this for the volume. Volume is equal to what? I'm going to multiply across by volume or divide by R, so I get rho aluminum L squared all over the resistance R. But I know the voltage and I know the current. And so in fact, I do know the resistance R. This becomes rho of aluminum L squared divided by R. And we know that V equals IR, and so R equals V over I. So we can put that right here, V over I. And now I think we almost have all the numbers that we need for there, but we still want to get mass. So mass M is equal to rho mass. This is unfortunate that we're using rho for mass density and also for conductivity or resistivity, but that's just how it goes. And we got to multiply by volume, which we said was this. So we get rho aluminum L squared, that I flips up in top, and we get a capital V for voltage in the bottom. And now we have all those numbers. We have the mass density right there, 2,700. We know what rho aluminum is. We just did that earlier. We can look it up in the book. We've got I, we've got L squared, and we have V. And if you plug in all those numbers, what do you get? Well, let's just do it again right here. We've got 2,700 for rho, the mass density. Aluminum, we said, was 2.82 times 10 to the minus 8. L was 175. I was, what did we say for I? 125, right? 125 amps. And then let's divide the whole thing by V, which was 0.3 volts. Okay. And if you punch in all those numbers in your calculator, you can double check me, but I got a mass M for that wire of 971 kilograms. Okay, which is a pretty big wire, right? It's almost a metric ton, but it's long and it's carrying a lot of current, which means it's going to have to be quite thick.